Why are we laughing? 221, 220, 2020. Just focus. Kind of. Okay, so who has heard of Hess's law? I don't think it was on the quiz. It shouldn't have been on the quiz, at least not, I don't think so. Who's heard of it from some other chemistry class? Who knows what it means or remembers what it means? That's fine. All right, so Hess's law states that when reactants are converted to products, the change in enthalpy is the same. Oh, yeah, okay. Is the same whether the reaction is happening, whether the reaction takes place in a single step, one step, or a series of steps. Total enthalpy change, delta H, is going to be equal to the sum of all the individual changes for each step. So this is sometimes called heat of summation. Might be like a phrase used with Hess's law. On the homework I ask you, do this with Hess's law. It's pretty explicit. Okay, so let's do a quick example. Let's say I want to convert, I want to make CO2 from its elemental constituents. Let's say I have solid graphite. Who knows what the structure of graphite looks like? It's a bunch of hexagons of carbon. Who knows what graphene is? It's just like one sheet of graphite, one layer. And then you can roll it up into tubes, or it does a lot of fancy stuff. All right, plus I have some oxygen here. So this is combustion, and I'm going to make carbon dioxide gas. And my change in enthalpy, and this happens to be of formation because I'm making it from the elemental constituents, is equal to negative 393.5 kilojoules per mole, okay? I'm talking about standard state, so I know I'm making 1 mole. My negative makes sense to me. This is an exothermic reaction. It's releasing heat energy. I'm clearly forming a new bond, okay? Right? I'm forming more bonds than I'm breaking, so it makes sense that delta H would be negative. I'm happy with all that. So this is given to you. But alternatively, this synthesis could happen. This would be direct combustion. We could have an indirect combustion where first we make carbon monoxide and then we make carbon dioxide. So we can separate into 2 steps. So let's say we had, to keep everything in integers, okay, let's have 2 graphite plus 1 oxygen is making 2 carbon monoxides. Everybody's balanced. This would give delta H equal to negative 221 kilojoules. It's not in per mole. If I want to write this for standard state, just assume everybody's at 1 atmosphere and 298 K right now. Okay. The rest of the standard state requirements are in play. Okay. Delta H for standard state, I would divide this by 2. I've made 2 moles, negative 110.5 kilojoules per mole. And then I could have a second step where I'm reacting my carbon monoxide with another mole of oxygen. Okay, so this is my direct combustion. This is sort of, I have a first step of combustion, a second step to make 2 CO2. And this has an enthalpy change. I did this in a calorimeter and I get some heat flow out that I can use. This is 566 kilojoules, or in standard state, when I'm talking about only synthesizing 1 mole, I have negative 283 kilojoules per mole. And so then what I do is I can just sum these up. It's the heat of summations. The total change in enthalpy will be given by the sum of all the individual changes in enthalpy. So the sum of the 2 steps is 0.5. This is 393.5. Negative 393.5 kilojoules per mole. Checks out. Like I said, I gave these values to you, but you had a whole table of them to do it with. So a couple of notes really quick. Enthalpy of formation, if this value is less than 0, then another way to think of this is that the compound is more stable than the elements that it's made out of. Obviously, alternatively, if the enthalpy of formation, and remember, so this one here is not an enthalpy of formation because I have CO in this step as a reactant, but this one would be. I could still write this and it would work, okay? If it's greater than 0, then obviously the compound is less stable. Yeah. And just keep in mind that this term here, for this equation where I'm doing the sum of all the entropies of my products and my reactants, I have sort of no delta because it's not of formation. My standard state entropy is not equal to 0 for elements. It's not equal to 0 for anything. And this right here, it could be of formation or not. It depends on whether the reactants are all elements or not, okay? Whether or not you want that subscript there. Yeah. If yes, it's of formation. If not, it's not.